Meteorological measurements at the Polish Polar Station. Dramatic changes taking place in the climate and environment of the Arctic over the last decades are clearly visible in the data collected through meteorological monitoring conducted at the Polish Polar Station Hornsund. The station was established in 1957 in southern Spitsbergen, which is the largest island in the archipelago of Svalbard, and has been functioning non-stop since July 1978. It is the only all-year Polish observatory in the Arctic. Meteorological measurements are carried out in collaboration with the Norwegian Meteorological Institute, and weather information is systematically sent to the World Meteorological Organization in the form of coded SYNOP reports. The Polish Polar Station is part of a global measurement network, and all relevant observations and measurements are conducted in keeping with WMO standards. Every hour, basic meteorological information is automatically sent to the head office in Oslo, and every 3 hours, it is supplemented with visual observations of cloud cover, visibility, and weather conditions carried out by meteorologists. The observations are conducted regardless of the weather, which means that the observers must do their job during the polar night, snow blizzards, or heavy storms. They always carry firearms too, in case they should encounter a polar bear. Meteorologists working at the Polish Polar Station gather, process, and interpret data from a range of measurement devices found in the local weather station. The station is located on a raised marine terrace 10 meters above sea level, at a distance of about 300 meters from the shores of the Hornsund Fjord. The MAWS 301 automatic weather station is installed on a measurement mast. The main data logger is a box found in the mast's bottom part. The device automatically collects and records data from sensors plugged into it, which measure particular meteorological parameters. At the same time, data from the logger are visualized and recorded on a computer located in the weather office, which occupies the corner of the station's main building, 160 meters away. 2 meters above the ground, on a crossarm extending to the side of the mast, is a radiation shield, sometimes referred to as a Stevenson screen. It allows air to freely pass through, while at the same time protecting the sensors from various factors that could distort the measurements. These include direct solar radiation and atmospheric precipitation. Inside the screen is a thermometer for measuring air temperature and a hygrometer, which measures the Earth's relative humidity. So far, the lowest air temperature recorded in Hornsund was -35.9 degrees Celsius, recorded in January 1981, and the highest was 16.5 degrees Celsius in July 2020. Higher crossarms support radiometers, which measure solar radiation, and a PWD sensor for measuring visibility and the type and intensity of precipitation. At the height of 10 meters above the ground, anemometers installed at the top of the mast measure wind speed and direction. Extending from the mast are also sensors which measure soil temperature down to 12 meters beneath the ground. Atmospheric precipitation is especially tricky to measure in polar conditions because of frequent strong gusts of wind and snow blizzards. The meteorological station contains 3 rain gauges, also known as pluviometers, a Parseval laser gauge, Gionor weighing gauge, and a classical Hellman rain gauge. Nearby stands a ceilometer, which determines the height of the cloud base and the vertical distribution of aerosols. Inside a screen on the ground level sits an evaporimeter, which measures the rate of water evaporation. If we look around, we can also see 3 snow measurement stakes. They help to determine the depth of the snow, which covers the ground in Hornsund for about 240 days a year. A Campbell-Stokes heliograph is a glass sphere that acts as a lens. It converges sunlight so that it burns a trace on a properly marked strip of paper. By measuring the length of the trace, we can determine sunshine duration to an accuracy of 1/10 of an hour, or 6 minutes. The Arctic is an unusual place in that, because of the midnight sun, Solar radiation is measured around the clock, and during the summer season, 3 heliographs are needed to do the job. Data collected in Hånsund are used to create weather forecasts and provide information about climate variability. Besides, meteorological measurements form a background to all sorts of scientific studies conducted here, in fields including hydrology, glaciology, but also ornithology and tundra biology. Observation results of such phenomena as UV radiation or aerosol variability are sent to the International Aeronet Network and NASA. Climate changes observed in Hånsund reflect the global trend of climate warming, which here takes place a lot faster than it does at lower latitudes. Within the last 4 decades, mean annual Earth temperatures have risen by 4.5 degrees Celsius, from more than -6 degrees Celsius to less than -2. The change is 6 times the global average. The amount of rainfall is rising dramatically too.
The material was prepared for the project EduArctic 2, From Polar Research to Scientific Passion, Innovative Nature Education in Poland and Norway, which receives a grant of €240,000 received from Iceland, Liechtenstein and Norway under EEA funds.